So welcome to the video where we're going over the Cambridge A-Level Pure Paper 1 Version 1 exam. Let's go. So for this first question, we need to find the set of values of m for which the line with equation y equals mx minus 3 and the curve of equation y equals 2x squared plus 5 do not meet. Okay, so for this question, if we consider that they were to intersect and meet at a certain point, then we would have 2x squared plus 5 is equal to mx minus 3. Okay, now if we just bring everything to the left side, we end up with a 2x squared minus an mx, and then we get a positive 8 is equal to 0. And now we have a quadratic equation, and if we consider the discriminant, okay, we know that for something to not have any solutions, it is when b squared minus 4ac is less than 0. So we just apply that to the values we've been given. So for this, if we consider that a would be 2, b would be a minus m, and a c would be an 8, and then we apply b squared minus 4ac, we get a minus m squared minus a 4 times a 2 times an 8, so actually that will give us a minus 64, and that will be less than 0. Then that would be an m squared minus 64 is less than 0, so m squared is less than 64. And then for this, remember when inequalities, when we are doing the square root, we should actually write it that it will be the mod of m is less than 8. So by doing that, what that means is we consider just the positive and the negative variant of m. So therefore, we would have that m is less than 8 here. And also, we need to also consider that it's the modulus, that minus m would be less than 8, which if we were to make m just the subject, then we need to change the inequalities. So it'll be m is greater than minus 8. And therefore, we have these two values. We have m is less than 8, and we have m is greater than minus 8. Therefore, it must be that the values between minus 8 and m, so we can write it like this, where minus 8 and with less than m, which is less than 8. So this question here, we've got the equation of a curve is such that dy over dx equal to 1 over x minus 3 squared plus x is given that the curve passes through the point 2, 7. Find the equation of the curve. So this question, just before we start, just be careful not to work out a straight line, because we've got dy over dx, and you may just think, oh, we've been given these points 2, 7. If we just put 2 into this equation, it'll give us our gradient, and then we can just apply the straight line formula, work out the straight line, it's all good. But just be careful that it says the curve, okay? And when it says the curve and they give us dy over dx, that means that we have to integrate, okay? We're going to have to integrate to work out the equation, okay? So if we integrate this, well, I'm going to rewrite this just slightly in a different way. So I'm going to do dy over dx is equal to x minus 3, and I'm going to write this to the minus 2, okay? To the minus 2 and then plus x. And now I'm going to integrate this. So if I integrate this, that would be we would get a y is equal to an x minus 3, and then we just add 1 to the power, that's minus 1, and then we just divide by that, so that would be a minus 1. And then for the x, that would be an x, and then we add 1, so that would be a 2, divide by that new power, so it's a 2, and then we just plus our c value, okay? Now, one thing they do tell us in the question as well is we do have our limits of we know that it passes through 2, 7. So in a minute we will use those points, but for now let's just clean this up a bit. So we get y is equal to a minus x minus 3, okay, to the 1, and then we can leave this as x squared 2 plus c. Actually, let me just do this again. Let's put this as a fraction. So x minus 3 plus x squared to the 2 plus c. And we know what our values are. They tell us that when x is 2, y is equal to 7. So now if we put in those values, we get a 7 is equal to a minus 1 over a 2 minus 3, so that's a minus 1 there. And then we get a 2 squared over a 2, so that's a 2 plus a c. So we get 7 is equal to a minus 1, so a positive 1 plus 2 plus c. So we get a 3 on this side, so therefore we would get a c is equal to a 4. And then once we do that, we can just put that as our c, and then therefore we know our equation is going to be a y is equal to a minus 1 over x minus 3 plus a x squared over 2 plus a 4. In this question, we have air is being pumped into a balloon in the shape of a sphere so that its volume is increasing at a constant rate of 50 centimeters cubed per second. Find the rate at which the radius of the balloon is increasing when the radius is 10 centimeters. Okay, so with this question, what do we know? Well, we know that we're told that its volume is increasing at a constant rate of 50 centimeters per second. So when this is at constant rate, we know that we're dealing with a differential equation. So let's think of the differential equation. What would it be? Well, if it's volume and it's increasing at a constant rate, we know we're dealing with volume, so we have dV. And then if we look at the unit, it says 50 centimeters cubed per second. So therefore, we're dealing with time as well. So, dV over dt is equal to 50. And then it wants us to find the rate at which the radius of the balloon is increasing when the radius is 10. So note the radius is 10, and what do we want to find out? Well, if we want to find the rate at which the radius increases, and that would probably means we need to find out what dr over dt is, okay? Now, how can we find out what dr over dt is? Well, questions like this, we're usually going to have to use previous information, so we know what dv over dt is, and what that effectively means is, because we know what dv over dt is, more than likely we're going to have to work something out like this, where dr over dv times a dv over dt, and that will give us our dr over dt because the dv's would cancel out. So we know what dv over dt is. Well, can we work out what a dr over dv is? Well, yes, we can, okay, because dv over dr, or not even dv over dr, we can get an expression for the volume of a sphere in terms of r, right? Because we know that the general formula for the volume of a sphere is 4 over 3 pi r cubed, okay? And they tell us that we need to find the rate at which the radius of the balloon is increasing when the radius is 10. So what we can do actually is, if we was to differentiate, that would give us dv over dr. And then we can just do the reciprocal, and then that will give us dr over dv. So that's what we're going to do now. So if we work out dv over dr, well, we just need to differentiate this with respect to r. So then with a 4 over 3 times a 3, well, what would that be? That would just be a 4. And then a pi stays the same, and we bring the power down by 1. So therefore, 4 pi r squared. And we know that they tell us in the question that we want it when it's 10. So now we input our 10. Make sure we don't do it too early. Now we want to input our 10 because it's when it's increasing. So now we input our 10 for the radius. So that'll be a 4 pi times by a 10 squared. If you work that out, you get a 10 squared is 100. And then times by 4, so that would give me a 400 pi. So now we know that dv over dr is 400 pi, and we want dr over dv. So dr over dv would just simply be a 1 over 400 pi. And now we have everything we need. We know what dr over dv is. We know what dv over dt is from the question. It's 50. So therefore, if we work this out now, we have a dr over dt that is equal to a dr over dv, which is 1 over a 400 pi, times by the dv over dt, which was just 50. Therefore, we get a 50 over a 400 pi, which simplifies down to a 1 over 8 pi. So question 4, okay, we've got this diagram, and the lower curve is the equation of y equals cosine theta. The upper curve, that shows the result of applying a combination of transformations to y is equal to cosine theta. We need to find, in terms of a cosine function, the equation of the upper curve. With this question, there are loads of ways to do it, but I'm going to give you a way which you can pretty much use for all of these type of questions if you're unsure of what it is, because sometimes with these questions, even that may seem easy, it's very easy to make mistakes. So I'm going to show you a way which you can do it. So let's start with just the y direction first, okay? So as you can see, just from looking at the graph, we know that it's definitely being transformed in some way in the y direction, okay? And what we're going to do is we're going to look at some values first, okay? So what we can do is let's think of two values, okay? Let's, in the y direction, if we look at this value here, okay, this 1, well, where is this 1 mapped to in the transformation? It is mapped right here to that 5, okay? It's mapped to that 5. So that 1 maps to the 5. So if I just make a note of that, we're dealing with the y direction, okay? We know that that 1 gets mapped to the 5. And with these other questions, because we're dealing with the y direction, then there's something we can actually, an equation we can form. Because if something is moving in the y direction, when we consider the scalar aspect or any shifting in the vertical direction, okay, then that is y is equal to a f of theta plus b. And we can apply this to what we've got now. So for example, in this case, if we know f of theta, in this case is equal to 1, right? Because that's the original function, right? Let's say f of theta was equal to 1. Well, now when we apply the transformation, it's now 5. So what we can say is 5 is equal to a f of theta. In this case, f of theta is 1 because that's what it originally was. So therefore, it would be a times 1, which is a, plus b. So now we've got a plus b is equal to 5. And now that's just an equation. But what we can do is we can now just take another point and do the same thing, and then we're going to have simultaneous equations, and we can solve what the scalar value is and what the shift is. So let's take another point. Let's take what point should we take? Let's look at when the graph is at its lowest point, right? So let's look at the minimum. So know that in the original graph we have a minimum at pi, okay, because it's right here, and not pi, my bad. We care about the y direction. So actually, again, we're taking the minimum, but actually we're looking right here. So we know that it's going to be minimum at -1, okay, and we look at again the y direction where it has its minimum. Well, we know that in the transformation, the minimum is now at 1, okay? So in the original, it's at -1, and the transformation is at 1. So again, that's another mapping, okay? So we know that we've gone from -1 to 1 in the y direction, right? And we can apply that same formula which we just did. The y equals a f of theta plus b. But now, in this case, the original equation, we would have had f of theta is equal to -1. So if we do the same thing, well, y in this case would be a 1, okay? Because that's what we get in the end. We get y as 1, so we get a 1 here. And then we get an a times a -1, so it's a minus a plus a b. And then we can leave it like that. So now we've got two equations, okay? If I write them down here, we've got a 5 is equal to an a plus b, and we've got a 1 is equal to a minus a plus b. Okay, so it's equation 1, this is equation 2. And now we've got simultaneous equations, so we can just solve. So if we do the equation 1 plus equation 2, that will get rid of our a values. So if we do that, we get 5 plus 1, which is 6. Our a's cancel out, and we get a 2b. Therefore, we know b is equal to a 3. And therefore, we also know that a would be equal to a 2. So we've worked out our a and b values now. So now we know that in the y direction, we get that y is equal to a, which is 2, f of theta, okay, which would be our cosine theta. I'll put that in later. And then that would be a plus our b value, which is a 3. So now that we've done this in the y direction, we're going to do the same thing in the x direction, okay? And the formula for the x direction doesn't change much. It changes slightly. But what you can do is you can use this formula in the x direction. So x would be a c theta plus d, okay? So, and we can apply the same type of formula, which is what we just did now. So now we're going to look in the x direction, okay? And we're going to look at points in the x direction, see where they've been mapped. So let's see, what points can we do? We can use any points we want to use. So let's say I'm going to use this point here. So again, I'm going to use the minimum, and we know the minimum is at pi, okay? And then if we look at the minimum when it's been transformed, it's gone from pi, it's now at 2 pi, okay? So what do we know? We know that pi has been transformed to 2 pi in the x direction. And we can apply that same thing. So in this case, we know that theta, that originally was pi, but now we know that it's 2 pi, so now our x value is now going to be a 2 pi, okay? And we apply that same formula. So therefore, we get a 2 pi is equal to a c pi plus a d. Okay, and we can't do anything with that yet because we don't know what our values are. But again, we're gonna find another 2 points to map, and then we're gonna have simultaneous equations. So the points I'm gonna use now is, let's use this point here, okay? Like at this point here, that kind of midpoint, we know that this value here is like a pi over 2, okay? So we know that this is pi over 2, this would be pi over 2, it's in the middle of 0 and pi, and that maps to this point here, which is pi. So therefore, we also know that pi over 2, that maps to pi. And we apply the same formula. In this case, we would have a theta as a pi over 2, and the x value would be a pi. And we just apply the same formula. So therefore, a pi would equal a c theta, okay? So that's a c pi over 2, and then that would be a plus d. And therefore, if we write down the other equation we had 2 pi is equal to c pi plus d. And as you can see, we have this type of equation. Let's label this equation 1 and equation 2. As you can see, our d's would cancel out any way we do it. So I'm going to do equation 2 minus equation 1. So that therefore I'll do a 2 pi minus a pi, so I get a positive pi. Then I get a c pi. I'm going to leave this as c pi minus a c pi over 2. And then our d's cancel out. Therefore, if we were to work this out, we would get a pi. And then I'm going to factorize out the c. So we get a c, then in brackets pi minus a pi over 2. And then we know that pi is equal to, actually no, let's do a c is equal to a pi over a pi minus pi over 2. If we work this out, we get a pi over a pi over 2, because pi minus pi over 2 is just pi over 2. And therefore, if you work this out, pi divided by pi over 2 would be the same as pi times a 2 over pi, which gives us a 2. So we know that c is 2. And if we know that c is 2, therefore we would have a 2 pi is equal to a c pi. Well, we know c is 2, so that's a 2 pi plus d. And as you can see, d would have to be 0 in that case. So d is 0. And that does make sense, okay? Because what they're saying when d is 0 is that we actually haven't shifted in the left or right direction at all. Because we have just c as 2, what that means is effectively everything has been like halved, or not half, but everything's doubled in the same region, okay? So that's actually all that's happened in the x direction, okay? Everything is like oscillating twice as much. And when we consider this, okay, when we consider this type of question, because we've got that c is 2, if we go back to our equation, effectively we would have something like x would be like 2 theta, okay? But again, as I just said, what it really means is that x is actually kind of oscillating like twice as fast. So when we consider this in this type of question, it would be the reciprocal, okay? So once we get an answer for c, we do the reciprocal when we put it into the function. So if I just clean this up now, we have if I write what we originally had as well. So we know that y was equal to a 2f theta plus 3. Well, now that we've got the x value, we need to put the x value in there, but the x was actually 2 theta, so actually we do the reciprocal of that. So all that ends up happening is we get y is equal to a 2f a half theta. Okay, remember that we always do this. We always need to do the kind of reciprocal because it's actually the opposite of what we actually want. But with half theta, that shows that it's going to be oscillating like as double as much in that region. And then we can plus the 3. And now at this stage, all we need to do is just put in our values now. So we get y is equal to a 2 cos, remember f of theta was cos theta, so 2 cos a half theta, and then that would just be a plus 3. So it's a bit of a long-winded way to do it just for 3 marks, but it's a surefire way to make sure you do get the marks if you can't see the answer already, okay? So for part A, we have in the expansion of 2x squared plus a over x to the power of 6, the coefficients of x to the power of 6 and x to the power of 3 are equal. We need to find the value of the non-zero constant a, okay? The value of the non-zero constant a. So how can we do that? Well, we know that we're going to have to use some of the binomial expansions, okay? So let's go with that. So first thing first, if we want x to the 3, well, we can do 6 choose 3, and that'll be a 2x squared to the 3, and then we'll also get times by an a over x to the 3, okay? And let's work this out. So if we were to work this out, we would get a 6 choose 3 is 20, and then we would get a times by an 8 x to the 6, and then we would get a times by a to the 3 over x to the 3. And if we work this out, what do we get? Well, we would get a 160, and then the x's, we get that would go to a x to the 3 because x to the 6 divided by x to the 3 was just an x to the 3. And we also have that a to the 3. Let's write the other way. So let's write that as a to the 3, x to the 3. Okay, so now we need to work out x to the 6. We've just got to be very careful. You may think, oh, let me just do 6 choose 0, and then that will give me like a 2x squared to the 6. But then if you used to work that out, right, you would get a 2x to the power of 12, okay? And we don't want a 2x to the power of 12. So you should be very careful about how you do this one. So actually with this one, you got to think about what value would give me x to the power of 6. Actually, it would just be 6 choose 4, okay? Because 6 choose 4, and if we work this out, that will give me a 2x squared all to the power of 4. And that will be times by an ax squared, okay? And now when we work this out, we can see that we're going to get, for this, we're going to get an x to the 8, and then divided by an x to the 2 would give us the x to the 6, okay? So just be careful of that. So if we work this out now, what is 6 choose 4? 6 choose 4, that will give us a 15. 2x squared all to the 4, that will give us a times by 16 x to the 8. And then we get times by an a squared over x squared. And if we work this out, what do we get? Well, what's a 15 times a 16? Put into your calculator, you get a 240 a squared. And then, as I said before, x to the 8 divided by a x squared, that is an x to the 6, okay? So we've worked out. So, and we know that the coefficients must be equal. So we know that a 160 a because the coefficients must be equal. If we have these two values here, so we have 160 a cubed x cubed and 240 a squared x to the power of 6. Our coefficients must be equal. Therefore, 160 a cubed must equal 240 a squared, and yeah, we can just work this out. In the question as well, they just tell you that it's a non-zero constant. That's important. So the way you want to do this is if we bring that 160a3, we bring the 240 to this side, we get it like this, and then you want to factorize out. Now, Obviously, we could just divide both sides by a squared as well, but you got to be careful because in this question, it will be fine. You'll still get the right answer, but you could have a question where you actually lose a solution. You will lose a solution of 0, okay? And you don't want to lose a solution of 0 if your question wants it. So luckily in this question, it says that it's a non-zero constant, but it's a good practice just to factorize it rather than just divide by a squared. So we're going to factorize it, and we can take out 80 and a squared, okay? And then we'll be left with a 2a minus a 3, and that is equal to 0. So as you can see, 0 is a solution, okay? Because obviously we get an 80a squared is equal to 0, which means that a is equal to 0. But obviously in our question, we obviously don't want that because it's a non-zero constant. So we would just disregard our 0, but it's always good practice just to do it like this for future questions. So we now just have that a 2a minus 3 is equal to a 0. Therefore, if we work this out, we get a is equal to a 3 over 2. And yeah, that's our answer for A. So for this question, okay, so 1 marker, but it really should be more. I said at least 2. But yeah, we need to find the coefficient of x to the power of 6 in this expansion. So what they've done now is they've added this 1 minus x to the 3, okay? So they've added that. So what that means is there are 2 points now where we can get x to the 6, okay? So looking at our previous one, we know that for our previous question, okay, we know that we had a 160a cubed x cubed, okay? And we know that in our type of question, if we get that and times that by the minus x to the 3, that will give us an x to the 6. So if I write that down here, okay, we know that we get a 160 a3 x3, okay? And we know that if we were to times that by the minus x squared, because it would eventually get times by that, that would give us a value dot 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 of x to the 6, okay? So let's do that now. So if we do that, well, what was a? Well, we know that a is 3 over 2, so we can do 160 3 over 2 cubed, okay? And then we know that x to the 3 minus x to the 3, that will give us a value, okay? So if we work that out, if you do 160 3 over 2 cubed on your calculator, okay, what value do you get? Well, you would get a 540. So we know that we get a 540 x cubed, and then we times that by the minus x cubed, that will give us a minus 540 x to the 6. So that's one of our values for the x to the 6. The other one would be this 240 here, okay? We know this would also bring that because we can also need to times by 1. So for that one, it would just simply be if we have 240 a squared x to the 6, we do a similar thing. Just do 240 times by a 3 over 2 squared x to the 6, okay? And that will give us, if you do that in your calculator, 240 x 240 times by 3 over 2 squared, that will give us a 540x to the power of 6. And obviously we'd times that by 1, so just keeps it as 540x to 6. And then it's a weird one because actually we would just now add them up together and we get a minus 540x to the 6 plus a 540x to the 6. And that just gives us the grand total of 0. So the coefficient is just 0. So for this question, we have the equation of a curve is y is equal to 2 plus the square root of 25 minus x squared. We need to find the coordinates of the point on the curve at which the gradient is 4 over 3. Okay, so we need to differentiate this and then make the gradient equal to 4 over 3. That will help us work out our x value, and then we can work out our corresponding y value. Before I start, I'm just going to rewrite the curve as 25 minus x squared to the power of a half, okay? Because now when we differentiate, that'll be a bit easier to differentiate. So if we do that now, we get dy over dx, the 2 just disappears, and then with this bit here, so we would get a 2x, we get a minus 2x out, okay? So we get a minus 2x coming out of the bracket, and then That'll also be times by that half. And then what's inside the brackets at 25 minus x squared, we can now put that down by 1, so that'll be to the power of minus a half. And now if we clean this up, we get dy over dx. That would equal a minus x, and then in brackets 25 minus x squared to the power of minus a half. So now this would equal 4 over 3, because the gradient would be 4 over 3. So therefore 4 over 3 equals minus x, 25 minus x squared to the minus a half. And now what I'm going to do is, to get rid of that power, I'm going to raise everything to the power of minus 2. So we get 4 over 3 to the power of minus 2. That is equal to the minus x, and then in brackets 25 minus x squared. And then all of this is going to be raised to the minus 2. And don't forget the power to the half was here. And then all that will be raised to the power of a minus 2. So now, if we work this out, so 4 over 3 to the minus 2, well, that would be 3 over 4 squared, which is 9 over 16. And then we'd get a minus x, and that would be to the minus 2. And then the powers would cancel out here, half times the minus 2. So we'll just be left with a 25 minus x squared like this. So therefore, we'd have a 9 over 16, a minus, so that would be a minus 1 over x times by another minus 1 over x. So effectively, all that we would end up getting is, if you think about it, we'd end up getting a positive 1 over x squared like this, and then that'll be a 25 minus x squared like this, okay? So now at this stage now, what we can do is we can get rid of these fractions. So as you can see, if we times, so we're going to do two multiplications at once. So we're going to times by 16 and also times by x squared, okay, to get rid of both of our fractions. If we do that, if we times by x squared, we're going to get a 9x squared over here. And we're also going to times by 16 as well. So we'd get a 16, and that'll be times by the 25 minus x squared, okay? And now, as you can see, it's looking nice now. So if we just expand the brackets out, now if you do 16 times 25, that is 400, okay? And then that's minus a 16x squared. And then we would get a 25x squared, and that's equal to a 400. And then x squared, well, yeah, it would just would be just left with the 16. And then we get x as a plus or minus 4. So we've got these two answers now. We've got plus or minus 4. And you may think to just work out both those values, but you've got to be careful, because one of those values could lead to an extraneous solution, okay? Because over here it says find the coordinates of the point on the curve at which the gradient is 4 over 3. It just says the point. It doesn't say points. It just says point. There's only one point where it's going to have a gradient of 4 over 3. So if you were to work out both of them, you would probably lose some marks here. We actually only want 1 point. So even though we've got a plus or minus 4, one of those is most likely going to be an extraneous solution. So we need to disregard it. So what you can do now is actually, if we know the gradient should be 4 over 3, well, we can just put in our x values into our dy over dx and see if we get 4 over 3. So let's start with the 4. Start with the positive 4, okay? Well, if we put that to dy over dx, that will be a minus 4. Then we'd have a 25 minus a 4 squared to the power of negative a half, okay? If we work this out, we get a minus 4. Now we'd get a 25 minus a 16 to the power of a half, which would be minus 4, 9 to the half. And that would give us a negative 4 over 3. So as you can see, we want a positive 4 over 3, because this is a positive 4 over 3, but we get a negative 4 over 3 when we use a minus 4. So that answer is most likely not correct. But now let's use a negative 4 just to double check. We do negative 4, we get a minus 4, and in brackets 25 minus a minus 4 squared to the power of a half. So that'll give us a positive 4. We know that the 25, like of minus 16, so we get another 9 to the half, and then that gives us a positive 4 over 3. So just by doing that, we've now figured out that actually we have to use -4. So actually our only solution is when x is minus. So only solution is when x is a -4. So now that we know that, we can actually disregard like the positive, and now we only are going to deal with it when x is equal to -4. And now we know that, well, now we can just put that -4 back into this equation here. Okay, so now all we do now is we can now put this x value into our original curve, which was this y equals 2 plus the square root of 25 minus x squared, and that should give us our answer. So that down here, we get y is equal to a 2 plus the square root of 25 minus a minus 4 squared. And if you work this out, you get a 2. Then the square root of 25, that'll be 25 minus 16 is 9. Square root of 9 is 3, so we get 2 plus 3 is 5. Therefore, we know that the coordinates is -4 and 5. So for question 7, we just show that this trig equation here is equivalent to 2 tan squared theta. Okay, to do this one, what I'm going to do is I'm going to join everything together and put everything under one single fraction. So if we do that, that would be a sine theta, then we're times by the 1 plus sine theta. That'll be minus the sine theta times by the 1 minus sine theta. And that is all going to be over a 1 minus sine theta, 1 plus sine theta, okay? And now that I've done that, now let's expand the brackets out. So if we expand the brackets out, then we get a sine theta plus a sine squared theta minus a sine theta plus a sine squared theta. Okay, and then the bottom, since it's a difference of two squares, that will just be a 1 minus a sine squared theta. And now at this stage here, there's some cancelling we can do. The sine thetas, they cancel out, so we'll be left with a sine squared theta plus sine squared theta is a 2 sine squared theta, and that would be over. Now remember, when we have ones like this, remember that a 1 minus sine squared theta equals cosine squared theta, one of those trig identities. So therefore, the denominator would just turn into a cosine squared theta. And as you can see now, it's fairly simple to see what happens. We know that sine theta over cosine theta is tan theta. Therefore, if we do sine squared theta divided by cosine squared theta, we are simply just left with a 2 tan squared theta. And for part B, we now need to solve the equation for theta now when it's equal to 8 between 0 and 180. So again, we know that this whole equation is equal to 2 tan squared theta. So therefore, we know that 2 tan squared theta is equal to 8. So tan squared theta is equal to 4. Therefore, tan theta is equal to a plus or minus 2. So as you can see here, we have a positive and a negative 2, which means that, let me just start drawing my cast diagram now. If I draw my cast diagram here, then we know that if it's all stations towards Croydon. So if we draw it like that, we know that we're actually going to get limits in every single quadrant. Because we have a positive and a negative value for tan, we're going to have regions in every single quadrant. So if you do the inverse tan of 2 on your calculator, you will get a 63.4, okay, to one decimal place, 63.4. Now, because we have a negative 2 as well, oh wait, before I do that, don't forget we're also going to have it in this quadrant here. Oh, let me make that more straight. So we're going to have it in these two quadrants. That's when tan is positive. But then because we have a negative 2, we're also going to have it in when tan is negative. So we're also going to have it in these quadrants too. So it's going to be in every single quadrant, okay? Because we have positive and negative. And now in the question, they want it between 0 and 180. So we can just look at our class diagram, look at when it's going to be between 0 and 180. So the first one will just be the 63.4. And the second one would be in that sine quadrant here, be this one here, okay? And that would be 180 minus 63.4. And if you work that out to one decimal place, that will just be a 116.6 degrees. Okay, so 63.4 and 116.6. So for number 8, we have a geometric progression has first term A, common ratio R, sum to infinity S, and the second geometric progression has first term A, common ratio R, and sum to infinity 2S. We can show that R is equal to 2 capital R minus 1, okay? This question, what do we know? Well, if we start with the first progression, okay, what do we know? We know the sum to infinity, so we know S, that would equal A over A1 minus R, okay? But for that second one, what do we know? Well, the second one, it has a sum to infinity of 2S, so it's all relative to S. So therefore, the second one would be 2S, and that would be equal to an A over A1 minus a capital R, okay? Now, because these sum to infinities are relative to each other, that S and the 2S, that the S's are the same in both, right? So therefore, we can just equate these together, okay? We can make these simultaneous equations. So if this is equation 1, this is equation 2. Well, let's just times it by 2. Let's times equation 1 by 2. So we get a 2S, and that is equal to a 2A. Okay, that would be a 1 minus R. Okay, so now if this is still equation 1, we can just have equation 1 equaling equation 2. Okay, so therefore, because our s's are the same now, we both have 2s. That would be a 2a over a 1 minus r is equal to an a over a 1 minus r, like that. Okay, and now we can just simply cross multiply. So we get a 2a, and this is a capital R, by the way. So we get a 2a, 1 minus a capital R, and that is equal to an a, 1 minus R. And then let's just expand these out. So we get a 2a minus a 2a capital R is equal to an a minus an a R. Okay, so we can, that gives us an a minus a 2a R, and that is equal to a minus a R. And now let's just factorize out the a, so we get a, and that's a 1 minus a 2r. That's equal to just an a, and then we have a minus r in the brackets. So we can get rid of the a's, so we are left with a 1 minus a 2r is equal to a minus r. And you can see, to get that into the form we want, we can effectively just multiply everything by a minus 1, or we can just change the signs around, and we can pretty much just show that r is equal to a 2r minus 1. So for part B, we're told that the third term of the first progression is equal to the second term of the second progression. Express S in terms of A. So to do this one, well, what do we know about the terms? Well, we know the formula is an is equal to a times r to the power of n minus 1, where a is the first term, okay? So in this case, it would be a3 is equal to a times r squared, okay? That's the first progression. And for the second progression, the general term would be a again, where a is the first term, times by a capital R n minus 1. Therefore, a2 is equal to an a times an r. Okay, so if I just whereas here we know this would be an a r squared, this one would be an a capital R, like this, and we know that they are going to be equal to each other. So what do we know? We know that an a r squared must equal an a capital R. Now, because we know that, actually, we can actually get rid of our a's because our a's are the same. So if we get rid of our a's, cancel them out because they cancel out, we're just left with an r squared is equal to a capital R. So now that we know that, okay, we know from the previous question as well, we know that r is equal to 2 capital R minus 1. So now we can just use the fact that r squared is equal to r, we can put that into our equation. So if we do that, we would get an r is equal to 2r squared minus 1. So that's an r is equal to 2r squared minus 1. And as you can see, we're going to end up with a quadratic equation here. So 2r squared minus r minus 1 is equal to 0. Now, if you work out this quadratic, you would get r is equal to 1, and you get r is equal to a negative half. But which one should you use? Well, you need to remember that because we're dealing with a sum to infinity, okay, we are dealing with a convergent geometric series here. And therefore, in this case, for a convergent one, we know that for a convergent one, the modulus of r has to be less than 1. So therefore, we have r is equal to 1, which is something which we don't want. So we disregard that one. And therefore, we only consider that when r is equal to a negative half. And now that we know that our little r value has to be equal to minus a half, well, we can just put it into the equation which we had at the start, where we had s is equal to a over 1 minus r. And if we do that, therefore we get a, and we want it in terms of a, so we leave a as it is, and then we get 1 minus a minus half, which is about to be 1 plus a half. So that's equal to a over 3 over 2. And therefore, you would get a 2 over 3a as your answer. Question 9, we have a diagram which shows a circle with center A passing through the point B, a second circle has center B and passes through A. The tangent at B to the first circle intersects the second circle at C and D. The coordinates of A are minus 1, 4, and the coordinates of B are 3, 2. Find the equation of the tangent CBD, okay? So we just need to find the equation of this straight line here. And we're also told that this point is minus 1, 4, and we're told that this point here is a 3, 2, okay? So how can we find that equation? Well, actually, if you think about it, if we can work out the gradient of this line, which we can, okay, let me use this one here. Yeah, if we can work out the equation of this line here, which we can do because we know the 2 points at the centers, well, if you look at these points here and this point here, there's a right angle forming, okay? And what does that mean? It means that, and because obviously it's a tangent as well, CBD is a tangent to that circle A, okay? We also know that it's gonna be a normal. Okay, this is going to be a normal here, and and by me drawing this as here, you can see that there's going to be a clear right angle forming here. So as a result, all we need to do is work out the gradient of the line from A to B, and then work out the perpendicular gradient, and then we can also use the points on B to work it out. So let's do that now. So we know that A and B we have minus 1, 4, and 3, 2. Let's work out the gradient of that. So that would be a 4 minus a 2. Okay, 4 minus a 2. And then we have a minus 1 minus a 3. So that would be a 2 over a minus 4. So that would be a negative a half. Okay, so we know that we know A to B it's a negative half gradient, which does make sense. It would definitely be a negative. So we know that this is a negative 2. So if we know that's a negative 2, we know that the perpendicular gradient, that would be a positive 2, okay? Because it's negative reciprocal. So we know that this line here has a gradient of positive 2, and it passes through 3, 2, as we know. So therefore, we know that our x value is a 3, our y value is a 2, and our m value is also a 2. We can use the equation of a straight line, y equals y1, and that's equal to mx, take away x1. Just plug in our values, that should give us our answers. So we get a y, take away a 2 is equal to a 2x minus 3. And therefore that would be a y minus 2 is equal to a 2x minus 6. Therefore, y is equal to a 2x minus 4. Okay, now for part B, we need to find the equation of the circle with center B. So what do we need to know? The equation of any circle is x minus a squared plus y minus b squared is equal to r squared, and that is in relation to a center of AB and the radius. I spelled radius wrong, and that is radius r. Okay. So we already know the center. We know that the center B. We know that has a center of 3, 2. So we already know that. So that's our AB values. We need to work out the radius. Okay. So how can we work out the radius? Well, this is how we can work out the radius here. Because if we look at this circle, well, the good thing about it is if we look at center B and look at center A, right? Center A is actually on it's on circle B, right? So we know that this distance here, okay, this actually is the radius. So if we can now figure out what we feel the length of that, well, that would just tell us that would help us work out the radius. Okay, so how can we figure out the length? Well, the drawing's a bit hard, but if I just do it here, if I just make it a bit more less straight and a bit more bent. So let's say we have a minus 1, 4 here, and we have a 3, 2 here. I've purposely drawn it like this, so that way it'll be a bit easier now when we come to do the length. So if we look at it like this, okay, and then let's just draw some dotted lines here. So as you can see, because we know that distance must be the radius, right? Therefore, we can talk at the length using Pythagoras' theorem. So again, to do that, just need to look at the difference. So as you can see in the x direction, right, we start at -1, we go to 3, so that is going to be a 4 here, and then let's say we start at 4, we go 2 down, so there's a difference of 2. So therefore, Pythagoras' theorem would be a 4 squared plus 2 squared, okay? And that's all square rooted, which would give me a square root of 20, which is a square root of 4, square root of 5, which gives me a 2 root 5, okay? So we know that it is a 2 root 5 is a radius, okay? But we can also leave that as root 20. But the key thing is we know that the radius is 2 root 5. So going back to this question now, we know everything we need to know. We know what the radius is, and we also know what our center is. So if we put all those values in, we get an x minus a 3 squared plus a y minus a 2 squared and equals r. Well, r was 2 root 5 or root 20, and then root 20 squared would just simply be a 20. Okay, so we can leave it like that. That is an equation of the circle. So for part C, we need to find by calculation the x coordinates of C and D. So all we need to do is work out what this point here, the x coordinate of that and the x coordinate of that. And we also know what the equation of the straight line is. We worked that out in part A. We know that the equation of CBD is y equals 2x minus 4. And we have the equation of a circle now. So we can just equal them to each other, simultaneous equations, and that should give us our x coordinates. So let's do that down here. So if I rewrite what it was, we know it was x minus 3. This is this circle, x minus 3 plus y minus 2 squared equals 20. That was the equation of a circle, and the equation of a straight line was y is equal to 2x minus 4. So now let's substitute in 2x minus 4 for y into the circle. That gives me an x minus 3 squared. Now we would get a plus a 2x minus 4 minus 2. Okay, so 2x minus 4 minus 2, that is a 2x minus 6 squared, and that is equal to 20. And now, as you can see, we just have x values. We can expand the brackets out and simplify down. But actually, looking at this, we don't actually need to expand the brackets out, because as you can see, we have x minus 3 and we have 2x minus 6, and I'm looking at that, and that to me looks like if we take a factor of 2 out of the 2x minus 6, we're going to end up with an x minus 3. So actually, we don't even need to expand the brackets out. We can actually take a factor of 2 out first, and then do x minus 3, and then all of that will be squared, and that is equal to 20. So now we end up with, scroll down, an x minus 3 squared, okay? And now we'll do a 2 squared. So we'll do a 2 squared, which is 4. So we end up with a 4. And then we're just left with an x minus 3 squared still is 20. So just a bit easier that way. We don't need to expand everything out. And now we've got x minus 3 squared lots, one lot of that, plus another 4 lots of x minus 3 squared. So that would just be a 5 lots of x minus 3 squared, and that's equal to 20. Therefore, 20 divided by 5, we end up with an x minus 3 squared, and that's equal to a 4. Therefore, we get x minus 3, that is equal to this plus or minus 2. So, therefore, we have two different possibilities. So let's consider when x is positive 2 first. We get a positive 3 plus 2. So we get a 5. And then we also get x is equal to a 3 minus a 2, which is a 1. So therefore, we know the coordinates. We have 1 and 5. Just looking back, we can clearly see then that the d would have to be 1 and the c would have to be a 5. So therefore, we can just write something here. So dx is equal to 1 and then cx is equal to 5. Okay, so for question 10, we have this diagram has a sector of CAB, which is part of a circle with center C, and then with a circle with center O, and radius R lies within the sector and touches it at D, E, and F, where COD is a straight line and angle ACD is theta radians. We need to find CD in terms of I and sine theta. So we need to find this line here in terms of R and sine theta. So, well, what do we know? Let's just put in that stuff we know. Well, we know that we have this circle here, okay, and it has radius R. Now, if this center O, then from O to D, that also has to be R. So we already know from O to D, it's R. And we want CD in terms of R and sine theta. So we've already worked out this bit here. We know that this bit here is just going to be R, okay? So that's done. Now we need to work out CO. We need to work out what this bit is here. So what else do we know? Well, we know that there's a right angle triangle here because that's like a tangent to the circle. There's a right angle there. And what else do we know? Okay, so we know that this is theta. So we have theta here. And we need to work out this line here, okay? Well, actually, we can actually work that out because we've got right angled triangle. We know we want to have the answer in terms of sine theta, and we have R. So if we consider using SOHCAHTOA, then this length is the hypotenuse. This would be the opposite, and then this is the adjacent. So we can use SOHCAHTOA to work out the length. Okay, so if we do that, what would that be? So we would get a sine. Because we already have opposite and we want to work, because we already have the opposite here and we want to work out the hypotenuse, we'd use sine. So it'd be a sine theta, because well, theta is just theta here. That would be the opposite. Opposite in this case is R over H. Okay, let's just keep it as H. And therefore, if we rearrange this, we know that H is R over sine theta. So because we know that, we can replace this now. And we know that this is R over sine theta. And therefore, if we know CO is R over sine theta, we know OD is R, then COD, well, it would just be them added up together. So therefore, we know that line CD is just simply going to be an R over a sine theta plus R. So the second question, we are told that R is equal to 4 and theta is equal to pi over 6. We'd find the perimeter of CAB now in terms of pi. Okay, so for this question, we need to work out the perimeter. So the perimeter is just going to be CA plus CB, and then with the arc AB here. So how can we work that out? Well, we know what CD is, okay? We know what this length is. We already worked this out in the previous question. We know that that was r over sine theta plus r. And what else do we know about CD? Well, we know that because CAB is a sector of a circle with center C, we actually know a very key thing. We know the length of CD must be the same as CA, and CB must be the same because it has a center C, which means that if BAD, if they're all like the edge of the circle, right, they all must have the same radius, right, the same length. So if we can look at the length of CD, well, then that would be the same as CA. So therefore, we know that CD is equal to CA, which is equal to CB. So if I just do that here, well, we know that we're told in the question that R is 4 and theta is pi over 6. So therefore, it would be a 4 over a sine pi over 6 plus a 4. Okay? And if you were to work that out on your calculators, you would get 12. So we know that CD, which is equal to CA, which is also equal to CB, is equal to 12. Okay? So because we know that this is 12 here, this is also 12 here. All we now need to do is work out the arc length. Okay, we need to work this arc length out. Okay, so we know that the arc length is L is equal to R theta. Okay, and we also know that this is also going to be theta. Okay, it's slammed bab in the middle, so we know that this is also going to be a theta, which means that in this case it's going to be a 2 theta. Okay, we're going to have a 2 theta in this case, and we know what r is because we just worked that out. It's 12, so therefore we know that in this case it's L is equal to 12 times by a 2 theta. Okay, and a 2 theta, that is L is equal to 12. Well, that'll be 2 times pi over 6, which is just going to be a pi over 3. And therefore that would give us a 4 pi. Therefore, we know that the arc length is a 4 pi. So therefore, it's 12 plus 12 plus 4 pi. Therefore, answer is 24 plus a 4 pi. For part C, we need to find the area of the shaded region now in terms of pi and root 3. So we need to find this region here. Okay, now how can we do that? So the way I'm going to do this is, if we think about this here, okay, now I draw that dotted line in because what we can do is we can work out the area of this triangle here, okay? And we know that whatever area of this triangle here, it'll be the same as this triangle here, okay? So therefore, we can work out the area of that shape. And then once we know that, well, look what we've got here. We've got a small arc. We've got a small arc here. So then we can work out the area of this small arc here, and then just do like this whole shape, take away this arc, and that should give us the area of that shaded region. So first things first, let's work out this triangle here. So what I'm going to do is, in order to work out the area, okay, I want to use a half AB sine C. I want to use a half AB sine C. But right now, so in order to do that, we need to know the included angle. So we know that this is a theta here, but we need to work out this side and this side, okay? So from the previous questions, we know that this side is r over sine theta. So if I work that out, we know that r over sine theta, well, we know that will just be a 4 over a sine pi over 6. And if you work that out, you get 8, okay? So we know that this length here is 8, okay? We know that that length there is 8. Now we need to look at working out the other side now, okay? So we want to work out this side here. So if I just draw like a little triangle here, so like this. Oh, what's the Let me do a more accurate one, like this. Okay, not the most accurate, but it does what I need it to do. So again, so if we have this, like F is here, and then O is here, and then C is here, we know that, so we know this is 8. Okay, we know this is R, which R is 4. And we know this is a pi over 6, okay? And we want to work out, let's say, this length here, which is x, okay? So we have actually loads of different ways. We know this would be the opposite. We know this is the adjacent, and we've also got the hypotenuse as well. So we can use sine, cos, or tan. We can use any of them to work this out, which is convenient. But just for the safe side, I'm going to use the 4, okay? Because we know that r is definitely 4. So if I do it that way, well, what do we get? We would get a tan, because we have opposite and adjacent, tan pi over 6, okay, that's equal to opposite, so 4 over x. Therefore, we know that our x is equal to a 4 over a tan pi over 6. And then if you work that out, you get a 4 root 3. So we know that the length here is 4 root 3. And now we worked out that, well, we have the two sides and the included angle. We can now work out the area of that triangle using a half AB sine C. So that would be a half times a 4 root 3 times an 8, and then times a sine theta. Theta's pi over 6, so a sine pi over 6. And if you put that all into your calculator, you get an 8 root 3, okay? So we know that the area in this is 8 root 3. And then we also know, if I get rid of these lengths now, we also know that the area in this is also going to be an 8 root 3. So therefore, it's like an 8 root 3 plus an 8 root 3. So we get the total of those areas is 16 root 3. So we now know that the area of all of this is a 16 root 3. Okay, so now that we've worked that out, we know that's 16 root 3, okay? Now let's work out the length of the arc, or the area of the arc, okay? So how can we do that? Okay, so now let's work out what this arc length is here. So first thing first, we need to work out what this angle is here. If we can work out what the angle is, therefore we can use that to use the formula of the area of an arc length, which is half r squared theta. So what I'm going to do, actually, let me just take this triangle I drew earlier. Okay, I'm going to bring it. I'm going to bring this triangle over here, expand it out a bit. Okay, and then if I just get rid of some of the stuff we don't need. So now what we want to do is we want to work out what this angle is here, okay? Because that angle is the same as this angle here. So if we can work that angle out, then we can use the formula for the area of a sector, okay? So in this case, because we work out that area or that angle, we know that this would be now the opposite. This would be the adjacent, and this would be the hypotenuse. So to work out that angle, I'm going to use, we have adjacent and hypotenuse. I'm going to use cos x is equal to adjacent, which is 4 over 8. So we know that cos x is a half. And if you do the inverse cos of a half, you would get, I know in degrees, that's 60, which means that that would be a pi over 3. So what do we know? We know that this is a pi over 3. And we know that this is also a pi over 3. Therefore, because we know that's a pi over 3, we know that if we were to add that up, that's going to be a 2 pi over 3. So now when we're dealing with the arc length, okay, we know the arc length is a half r squared theta. So therefore, we know what r is. R is a 4, as they tell us in the question. So we get half times by a 4 squared, and I guess it's times by pi over 3 plus pi over 3, okay? Because we can just add up these angles here. So we know that the angle is actually 2 pi over 3 here. So therefore we'd get a half times 4 squared, that is 8, times by a pi over 3 plus pi over 3, that is a 2 pi over 3. So therefore we get a 16 pi over 3. Okay, so we worked out everything now. We know that the the huge area, we know this area here is going to be 16 root 3. We know the area of the sector is 16 pi over 3. Therefore, the answer for part C, it would be a 16 root 3 minus 16 pi over 3. And yeah, you can leave your answer like that. So for part A, we need to just work out the expression of f(gx). So that will just be f(gx), and that is equal to 2x plus 1 squared plus 3. And with these questions, we should also state the domain and range as well. So for this question, okay, we know that x will have to be greater than minus a half. Because we have that x is greater than 0 and x is greater than half, then if you combine them, then x would just need to be greater than that minus a half to be valid, okay? And then for the range, well, for the range, we can consider both those points. And to be honest, for the range, if we just look at it as well, we can tell what the range is going to be, because 2x plus 1 squared, that's always going to give us a value greater than, or when x is going to be, or not x, when y is going to be greater than 0, when the function will be greater than 0. And then we have the plus 3 as well, okay? So in this case, we also know that the range, so we can just write like, also write that like f g of x will also be greater, or yeah, just greater than 3, Now for part B, we need to work out the inverse of f(gx), okay? So let's work out the inverse of f(gx). How do we do that? Well, the way I do it is I would write x here, and I would write a 2y plus 1 squared plus 3, and then I would solve this and make y the subject of the formula. So if we do that, we get x minus 3. Yeah, leave it as that for now, and that's 2y plus 1 squared. So now if we square root both sides, we get a plus or minus square root of x minus 3, okay? That is now going to be a 2y plus 1, and therefore we would get a 2y, and that is equal to a minus 1 plus or minus the square root of x minus 3. So we get y is equal to minus 1 plus or minus the square root of x minus 3 over 2. And for this question, in the previous question, because we knew that the domain of f of g of x, right? We knew the domain of f of g of x was when x is greater than minus a half. We now know that the range of f of g minus 1x, that has to be when this f of g of the minus 1x is greater than a half. So could we know that? We know that our y value, it has to be greater than a half. So if we look at this, we have minus 1 plus or minus the square root of x minus 3. So again, in order to make that greater than minus a half, we can see that for that plus or minus, the only way is if we get rid of that minus. So therefore y would just become a y is equal to minus 1 plus the square root of x minus 3 over 2. Because if you think about it, right, if y has to be greater than minus half, well, that x, the square root of x minus 3, okay, the square root of x minus 3, that has to be a value greater than 0, which means that it has to be a positive, which is why we can disregard the minus, and we're just left with minus 1 plus the square root of x minus 3 over 2. And now for the last bit, it says the question, we need to state the domain of f of g minus 1. Well, similar to what we just did, if we know that in the previous question, we know what the range is, okay? We know the range. So we know that the range of f g of x, okay, we know the range was when f g of x was greater than 3. So therefore, the inverse, it would just be the domain then, it would just be the exact same. So the domain of fg minus 1x would simply just be when x is greater than 3, okay? And that does make sense, because if you look at what we've got here, well, if x was any value less than 3, then it would have no solutions, okay? Because you get a negative square root, which you can't do. So it makes sense as well. So yeah, so we got an answer here of -1 plus the square root of x minus 3 over 2. And our domain is when x is greater than 3. So now we solve the equation when f(g) of x minus 3 is equal to g f of x. Okay, so let's solve this equation. So if we do that here, well, first thing first, we know what f(g) of x is. Okay, we know that f, with different color, we know that f(g) of x, work that in the first question, that was simply a 2x plus 1 squared plus 3. But we need to look at what g of f of x is. So what would g f of x be? Well, if we look back, we're just doing the opposite way, okay? We're just putting all of that, all the f of x into that x, into the g of x, okay? So that would be a 2x squared plus 3 plus 1. And now we know that, now we're to solve this equation. So it would be f of g of x, which is 2x plus 1 squared plus 3 minus a 3 is equal to a 2x squared plus 3 plus 1. And we just need to solve this equation. So we end up with a 2x plus 1 squared is equal to a 2x squared plus 3 plus 1. Let's expand the brackets on both sides, so we get a 4x squared plus a 4x plus 1 is equal to a 2x squared plus 6 plus 1. So bring everything to the left side, we end up with a 2x squared plus a 4x minus a 6 is equal to a 0, okay? And this actually can go down. We can divide everything by 2, so we end up with an x squared plus a 2x minus a 3 is equal to 0. And therefore, we can factorize, so that would be a x plus 3 x minus 1 equal to 0. So we get two solutions. We get x is equal to minus 3 and x is equal to 1. But just remember in the previous question, not the previous question, what they tell us in the question. Remember that here they have this domain here where x is greater than a half, okay? And we also worked that out for f of g of x. So what that means is x has, even though we've put it in this question, x still has to be greater than a half, okay? So because x still has to be greater than a half, then we disregard any solutions where x is less than minus a half. So in this case, we disregard this value here. So therefore, x is equal to 1, okay? So for this question here, we have a curve with equation y is equal to 4x to the power of a half minus 2x. And we also have the straight line, which is y equals 3 minus x. We're told the curve crosses the x-axis at 4, 0 and crosses a straight line at b and c. Find by calculation the x-coordinates of b and c. So to find the x-coordinates of b and c, fairly simple. As we can see, B and C are just intersections of the curve and the straight line, so we can just equate these equations to each other. So we get a 3 minus x, and that is equal to a 4x to the half minus a 2x, and we just need to work this out, okay? So what can we do? Well, if we bring the x to the side, we get a 3 plus x, and that's equal to a 4x to the half. And then we can actually just square both sides, so we get a 3 plus x squared, okay, and that would equal a 4x to the half, and all of that would be squared. And then if we just expand the brackets out, we would get an x squared plus a 6x plus a 9, and that would equal a 4 squared 16x. And therefore we get an x squared minus a 10x plus a 9 is equal to 0. And therefore we can factorize, so we get a x minus 9, x minus 1 is equal to 0. Therefore x is equal to a 1 and a 9. And yeah, that would be it. We've found the coordinates of b and c. If you really want to, we can either specify more what they are. So we can see that b has to be 1 and then c has to be 9. So over here we can maybe write something like b x is equal to 1 and then c x is equal to 9. So for part B now, we need to show that it's a stationary point on the curve. So we know that with stationary points, okay, therefore we know that f dash x, okay, has to be 0, okay, or dy over dx, how you want to look at it. So therefore, all we need to do is differentiate that curve, okay? Because we've shown that b is it, we just differentiate the curve. So we know that y is equal to a 4x to the half minus 2x. If we differentiate that, what do we get? We get a dy over dx, okay? That would equal a 2x, and then that'll be minus a half minus a 2. And how can we prove this is equal to 0? Well, we actually know what the coordinate is, okay? Because if we look up here, we're looking at b, okay? So we know it's this point here. We want to show that b is a coordinate. Well, we know that the x coordinate is 1. So therefore, if we substitute 1 into this, it should give us a 0. So let's do that. So we get 2, 1 to the minus a half minus 2. And yet that gives us a 2 times 1, which is a 2 minus a 2. We get a 0. So hence, it is a stationary point, okay? Stationary point. So for part C, we need to work out the area of the shaded region, okay? So it can be pretty difficult, this question, but effectively, the way you want to think about it is it's like a question where we're going to have to work out two separate areas and then subtract one from the other to get that area hit. So what do we know about this? Well, we know that what the straight line, okay? And the good thing about that straight line is, let's consider this. So if I draw this line here, right? Now we know that this point here, we actually know what that point is. Okay, we know that point has x coordinate 9 because we worked out the x coordinate of C, so that must have an x coordinate of 9, okay? We know this one has 4 from what they tell us. And we don't know what this point is here yet, but we can actually work it out because if you look at, if I do it here, obviously we have y equals minus 3x. Where does that line cross the x-axis? Well, therefore we can make y 0, 3 minus x, we get x is 3. So just like that, we know that this is 3. Now, why is that important? Because the reason I've drawn that line is because if we think about the area of this triangle here, this would be a right angled triangle, okay? There's a right angled triangle here. And we can work out the area of that, no problem. And then if you look, well, if we were to work out the area under the curve, okay, well, in this instance, if we think about it, the area under this curve, this particular curve, if we look at that between 4 and 9, well, therefore, it would just be this bit here. It would just be all of this bit here, okay? That would be the area under the curve. So we know that we can work that out through integration, and then we can also get the area of the triangle, and we can just subtract them. Now, just be careful. Be careful not to think that this is a right angled triangle here. It could be very easy to think this is a right angled triangle, but remember that this is actually a curve. It may look like a straight line at times, but it's not. It's a curve. Just be mindful that you don't do like the area of a triangle to this, and then that this bit here is a curve, so you can't work out using the triangle, okay? That's why we use integration, because integration will always be under the curve. And because it's under the x-axis as well, another thing to remember, because it's under the x-axis, we should get a negative value for area because it's under the x-axis. That's another thing to take note of. Okay, so first of all, let's work out what this area is here. Okay, let's work out what this area under the curve is. And to do that, that will be integration. So we can just use, it'll be integration of 9 and 4, okay? And it will just be of the 4x, not 4x squared, 4x to the minus a half minus 2x, okay? So that's what I'm going to do on this page here, okay? So let's do that now. So integration of 9 and 4 of 4x to the power of a half minus a 2x, okay? And if we integrate this, what do we get? So we would get a 4x 3 over 2, because we plus 1 to the half, and divide by that new power, so it's 3 over 2. And then we get a minus 2x squared over 2, okay? And then if we work that out, we get a 8 over 3 x to the 3 over 2 minus x squared, and then we can put in our limits now of 4 and 9, okay? So if we put in our limits, we get a 8 over 3 8 over 3 times 9 to the 3 over 2 minus a 9 squared, and that'll be minus a 8 over 3 4 to the power of 3 over 2 minus a 4 squared. So that gives me square root of 9, 3, so we get 27. So we get 27 times an 8 over 3, if I'm not mistaken. Okay, so what is a 27? So rather here, 8 over 3 times by a 27 minus an 81. And then for this one, we get a 64 over 3 minus a 16. Okay, so 8 over 27. Now I can see that that's going to cancel down. So 8 over 3 times 27, we're going to get so that's 8 times 9. So that's a 72 minus 81. And then minus that 64 over 3 minus a 16. Which if you work that out, you get a minus 43 over 3, which is perfect because we should get a negative because it's underneath the x-axis. But obviously, we're dealing with area, so we can just rewrite that as a positive now, so 43 over 3. So we know that the area under the curve, this bit here, we know that has an area of 43 over 3. Now we can work out the area of the right angle triangle here, okay? So now let's work out that area. So that area is fairly simple to know. If I just draw a triangle, let's do the triangle over here. So if I just have the triangle here, okay, and then we just need to work out really what the base and the height is. So we know that if we look here, we know that this is a 3 and this is a 9. So we know that it's going to have a distance of 6, okay, a length of 6 in that direction. And then we need to work out this area here. Now we know there's an x coordinate of 9, but we don't care about that. We care about the y coordinates now. So we know that this is on the x-axis, so it's going to be 0. And we need to work out what the y coordinate is here. So for that c value, well, we know that has an x coordinate of 9, okay? So if it's an x coordinate of 9, then, well, we know that the straight line is y equals 3 minus x, then effectively, all we need to do is just do a y is equal to a 3 minus a 9. And that gives us a minus 6. We know that the y coordinate is a minus 6. We know that if we had the coordinates, this would be 9 minus 6. And we know that this is a 9, 0. So we know that that would be a distance of 6 as well. Okay, it would have a height of 6. So therefore, a half times base times height, a half times 6 squared is simply just 18. So just like that, we've worked out the right angle triangle is 18, okay? So we know that the area of the triangle, okay, we know that is 18. We know that the area under the curve, we know is a 43 over 3. Well, therefore, all we need to do is one last thing. It would just be 18 minus a 43 over 3, because as we can see, it's going to be the area of the triangle minus the area under the curve, and that gives us this bit. This bit here. So 18 minus 43 over 3, put that into your calculator, and you get the grand total of 11 over 3, okay? And that will be it for this video. I've gone over this paper. Okay, not too bad. But yeah, I hope you enjoyed it, and I will see you on the next.